Hey guys, my name is Somnath Maji and again I am coming up with another new video. So today my topic is WEIERSTRASS inequality. So at first I will discuss the statement of WEIERSTRASS inequality. So here you can see that if a1 a2 ... an, so a1 a2 an are all positive real numbers less than 1, means a1 a2 an greater than 0 but less than 1, okay, and Sn equals to a1 plus a2 plus ... an. So what Sn refers here? Sn here refers that the sum of all positive real numbers which are less than 1, okay. These two are condition given, and for these two condition the WEIERSTRASS inequality, what we have to prove? We have to prove these two inequalities, that is 1 minus Sn less than 1 minus a1 into 1 minus a2 into 1 minus an less than 1 by 1 plus Sn, okay. So 1 minus Sn means 1 minus Sn means what? a1 plus a2 plus ... a plus an. So 1 minus a1 minus a2 plus minus ... minus an. 1 minus Sn means less than the product of all such real numbers in such a way that 1 minus a1 into 1 minus a2 ... 1 minus an less than 1 by 1 plus Sn, means reciprocal of 1 by reciprocal of 1 plus Sn, okay. So 1 plus Sn means 1 plus a1 a2 ... an, okay, and after getting 1 plus Sn we have to reciprocate this, okay. And the second inequality we have to prove, that is 1 plus Sn means 1 plus a1 plus a2 ... plus an less than the product of all real numbers in such a way that 1 plus a1 into 1 plus a2 ... 1 plus an less than reciprocal of 1 minus Sn, means 1 minus a1 minus a2 minus a3 minus an, and after getting this we have to reciprocate that, okay. And for the last inequality the given condition is Sn should be less than 1, okay. If this not happen, then this second inequality goes to infinity. So this is the statement of WEIERSTRASS inequality, and these two the statement for the given condition above, that is a1 a2 ... an all are positive and less than 1, and Sn equals to a1 plus a2 ... plus an, okay. Now I have to apply this inequality in some mathematics or some sum, okay. So here you can see this is a sum what I get. So I have to prove this inequality, okay. So the sum is 1 into 3 into ... 1 into 3 into 7 ... 2 to the power n minus 1 by 2 into 4 into 8 ... 2 to the power n, which must be less than 2 to the power n by 2 to the power n plus 1 minus 1. So here all of you know that 1 by 2 means 0.5, that is less than 1. 1 by 2 square equals to 0.25, which is also less than 1. So if we take a1 equals to 1 by 2, a2 equals to 1 by 2 square, and ... an equals to 1 by 2 to the power n, so this is also less than 1, okay. Now I have to apply the WEIERSTRASS inequality. So WEIERSTRASS inequality, what I will apply? The statement here I write 1 minus a1 ... 1 minus a2 1 minus a1 into 1 minus a2 into ... whatever be 1 minus an less than 1 by 1 plus Sn, okay. And Sn what gives the WEIERSTRASS inequality? a1 plus a2 plus ... plus an, okay. This is the WEIERSTRASS inequality I have to apply. and here you can so that the a1 is half, a2 is 1 by 2 square, an is 1 by 2n, okay, 2 to the power n, sorry. So I apply this a1 a2 an in this inequalities, okay. So 1 minus 1 by 2 into 1 minus 1 by 2 square dot 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 1 minus 1 by 2 to the power n, okay, less than 1 by 1 plus 1 by 2 plus 1 by 2 square plus dot 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 plus 1 by 2 to the power n, okay. So if we calculate the left hand side, then we get from this we get 1 by 2, it will give 2 square 4 minus 1 means 3 by 4 into dot dot dot, it gives 2 to the power n minus 1 by 2 to the power n, okay. Now if we product this left hand side, then we get 1 into 3 into dot 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 2 to the power n minus 1, and from below 2 into 4 dot 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 2 to the power n, okay. So the left hand side is similar what I have to prove. You can see the left hand side is similar what and this 1 3, you have to look 1 3 7 8. If we calculate the further third term, that is 1 minus 1 by 2 cube means 1 minus 1 by 8, then we get this 7 by 8, okay. So here we also get, if we calculate the third term, then 7, and in below we get 8, okay. Now we have to calculate the right hand side to prove this term, okay. So if we calculate this, you can see that this is the GP series, that for each term each term will be product by 1 by 2, from 1 to half product 1 by 2, and 1 by 2 to get 1 by 2 square we have to product 1 by 2 again. So this is a GP series, okay, where R is 1 by 2, and all of you know that for a GP series the summation of a GP series will be given by A into 1 minus R to the power n by 1 minus R if R is less than 1. So here R is what, half, which is also less than 1, so we have to apply this formula, okay. So we have, if we apply this formula here, so here A is 1, okay, here A is 1, and 1 minus 1 by 2 to the power n plus 1, okay. Why n plus 1? This is 1 by this, this, okay, because 1 we have to calculate the underneath the summation, okay. So okay, and the why I will give n plus 1, you have to see that here the number of term from 1 by 2 to 1 by 2 to the power n is n term, okay. If we include the 1, then I will get total number of term, that is n plus 1, okay. So from 1 to 1 by 2 to the power n, there are n plus 1 term, okay. So for this I have to write here 1 minus 1 by 2 to the power n plus 1, and in below 1 by 1 minus 1 by 2, okay. And next less than, and further we have to calculate this. So 1 by, and this will give 2 to the power n plus 1 minus 1, okay, and this 2 to the power n plus 1, and further calculate this, okay. All of you do well calculation or further, okay, this and this will give, if we calculate that, these two will cancel out in below 2 to the power n plus 1. Here if we simplify that 2 to the power n into 2, and this below 2 will be cut out by upper 2. So 1 by 2 to the power n plus 1 minus 1 by 2 to the power n, which is equals to what? 2 to the power n by 2 to the power n plus 1 minus 1. Okay, and left hand side we have to write 1 into 3 into 7 dot 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 2 to the power n minus 1 by 2 into 4 into 8 dot 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 2 to the power n. Okay, and you can see that the right hand side, this is the proof of the our application. The right hand side is similar what I gave in question. Okay, so this is the application and statement of WEIERSTRASS theorem or inequalities. You have further applied these inequalities in some math to rectify in future some problem. Okay, thank you for your support. Please do subscribe of my channel. Thank you for your support. Please do subscribe to get all the notification. Thank you.